So what we're demonstrating is the mission planning and management system. And what we're actually doing is executing a one-to-many collaborative mission between a ground asset and up to 9 UAV air assets. You can't necessarily stream 10 videos from assets or robots at the same time because you'll overload your network. So what MPMS does, it provides situational awareness of, I saw a target, I see it on the map, I can select that target only and see image chips. And also, when you're controlling robots, you don't want high frequency communications between them. So what we've done, the communications protocols that MPMS uses allow us to limit communications to low frequency communication, where you're just tasking them and they're autonomously, independently performing that mission. So one of the unique aspects of Plant and the MPMS planning is it's designed to give the subject matter experts, in this case, the soldiers or the people that understand the actual missions that are trying to perform, the tools to build those missions, rather than them having to go in the other direction, go to a software engineer and explain the mission to them to write code. So we're providing tools to people that are going to actually be designing and executing missions. And that also reduces the cost, right? So if you want to design a new pattern or a mission pattern, you can do it as a novice or not a software engineer without having to pay that cost to a software engineer. So we had 4 Rangers this week, and we trained them on executing the missions that we had designed on Monday. And they were able to quickly take the tools and run missions that were pre-planned. The next day, we trained them with the mission planning tools. And within an hour or two, they were actually able to design their own mission patterns. Execute those mission patterns with a simulation, refine the mission patterns in simulation, and then the next day, take those mission patterns, load them, and run them on the real system. So within 3 days, soldiers who had not been trained on the system were able to take the entire workflow, build mission patterns, execute them on real vehicles, and perform the mission that they had designed. We've designed the system such that with training, anyone should be able to create mission patterns and execute them. So once you've planned your mission pattern and you've assigned your assets, it's a single button push. So if you've planned a mission for 10 assets, you can press a single button, all of them will be assigned their task, and they'll all begin executing. Once they're executing, they can be communicating back and forth to each other based on that mission pattern to trigger events to happen. For instance, the soldiers had the ground vehicle cross a phase line, and that triggered multiple other vehicles to go, which then crossed other phase lines, trigger other vehicles to go. It provides safety and security for soldiers, but they should be able to project force farther, faster, and easier. And that will make their missions quicker and more capable. A few years ago, we decided to change the licensing rights to be government purpose rights. And what that really means is that the system is usable by any government entity or under any government contract without any external licensing. And so what that does, it enables the government to take the tools and build on them and improve on them without extra licensing costs when they are deployed in the field. You know, we have robots that are being fielded. We've got controllers and systems that are being fielded. Soldiers are being trained to use these robots. And now it's kind of an amazing time to start getting it into the systems where we've got actual multiple robots in the field controlled by this system.